1 through 10 here. My data numbers. 10 sets. 10 elements in my set, if I can make myself talk tonight. So n equals 10. So we want to look at measures of position. We talked about mean, median, mode last week. I don't remember, did we get to quartiles at all? Okay.
No, I don't think so.
I didn't think we had either. So actually what I want to start out with tonight is percentiles. Almost all of us have heard it somewhere that you took your test and you tested in the 85th percentile, or your weight is in the 38th percentile, or whatever. You hear the word percentile all over the place. And what the percentile means, let's say you're told that you are in the 38th percentile. That means that whatever item that is that you're measuring, whether it's a test score, height, weight, income, whatever, what that is saying is 38% of all people that have been tested, so we're just going to say 38% of everybody, is less than you, is less than yours. So if you tested in the 38th percentile on a test, you took the admissions test or whatever, and say you're in the 38th percentile. That means 38% of the people taking that test have a lower score than you. Of course, the other side of that is 62% have a higher score. So that's where your land is at that point within the data set. So obviously, if you test in the 98th percentile, you've done really well. It's not possible to test in the 100th percentile. The only way you could ever be in the 100th percentile is if you could verify that absolutely everybody in the world is less than yours. So there's only one person in the world that's in the 100th percentile for each category. So how do we find percentiles? Well, first thing I'm going to do is I'm going to find the number that's in a given percentile. So I'm going to move this data set down another notch. To find a number in a given percentile, it is all about position. So the position again is n times the percent. And just like before, if it's a decimal, round up. If it's a whole number, then it's between that one and the next one. I'll show you what I mean here. Do you ever have time to copy down the data set again? Do you need me a second?
I can just look back on the previous page.
Okay. So let's say I want you to find the 70th percentile in this data set. Well, to do that, I'm going to take n, which is 10, times 0.7. That's 70% as a decimal. What's 10 times 0.7? 7, right? So if I refer up here, that's a whole number. So that's telling me is that's between that position and the next one. So the 70th percentile is between the 7th and the 8th number. So it's between 27 and 29. Just like with the median, I add them together and divide by 2. So the 70th percentile for this data set is 28. Now, if you decide to use Excel for percentiles, Excel does some strange things sometimes. I mentioned last week in statistics, there isn't just one straightforward way of doing everything. There are some different schools. Percentiles, quartiles is one spot where there are some differences of opinion. And Excel uses an extrapolation technique, which is really, really tough to do by hand. So quartiles is one of the things that, percentiles and quartiles is one of the things that Excel does not do very well. I teach statistics for a couple of other colleges as well. And on a test, I can always tell when somebody used Excel to do their tests, because I know exactly what answers Excel will spit out for certain questions that aren't exactly what you would get if you did them by hand. Okay. Find the 28th percentile. Well, to find the 28th percentile, what am I going to do to find its position? 10 times 0.28. Good. And that gives me what? 2.8. Now that one falls under the category of the first one up here, being a decimal, which means we round up to the third position. The third position up here is 21. 21 is the 28th percentile. Find the 43rd percentile. Try that one in your notes quick. See if you can get it. So it's 10 times what? 0.43, which is 4.3. What do we do with that? Round up, yes, to the fifth. Even though it's only 4.3, we always round up. Because if we were to round down to the fourth number, 43% are not smaller than that one. So we have to round up. The fifth number in the list is 23. Now, this is ironic because if we rounded down to the fourth one, it'd still be 23. But we do have to round up. Most of the time, if you round down, it will not work. So that is finding the number that is in that percentile. Now let's go the other way. What percentile is the 29? So in what percentile is the 29, you could have asked? The formula for this is we have the number that are smaller plus the number that are equal divided by 2 all over n, the total number that are there. So here, 29 is right there. How many numbers in this list are smaller than 29? Say 7. There we go. 1, 2, 3, 4, 5, 6, 7 are smaller, right? How many numbers in that list are equal to 29? 1. So this will be 1 divided by 2, because the 2 is from the formula. How many total numbers are there in the list? What's n? 10. You got it. So this is 7 plus 1/2 is 7.5. Divided by 10 is 0.75. So I move my decimal point or multiply by 100, however you want to look at it to make it a percent. That is the 75th percentile.
So why is it a half? Why isn't it like 14.5?
Well, because it's considered to be greater than half of the number that are equal to it. Like, let me show.
You're talking about the one number, you're not actually dividing 29 in half.
No, I'm not dividing 29 in half. There's only one number that's equal to 29. Yeah.
Okay.
7 plus 1/2 is 7.5 divided by 10.
So with all these equations, it's basically variation on the same equation. We either flip the ideas or we do something to it so that it, I don't know, kind of work backwards.
Many of them are, yes.
Does that make sense?
Yep. And that's exactly what we're doing here. Is it's rather than finding what number is in that position, we're finding what position is that number in.
Yeah.
Yep. So looking at, let's say, the 23. How many numbers in this list are smaller than the 23? 3. Very good. How many are equal to 23? 2. Good. So it's 2 divided by 2. Over, and of course, n is still 10. So 3 plus 2 divided by 2, so that's 3 plus 1, is 4. Over 10 is 0.4. Move the decimal point or multiply by 100 or whatever, that is the 40th percentile. What do you think? Not so terrible? Okay. Strongly related to the percentile is something called a quartile. A quartile divides the data into 4 equal sections. In other words, each of those 4 sections has the exact same number of data points in it. Now, it sometimes confuses people. If okay, quartiles is 4, shouldn't there be 4 quartiles? No. If I have, let's say I have a piece of string and I need to cut it into 4 pieces, how many cuts do I need to make? 3 cuts. So it only takes 3 quartiles to divide the data into 4 equal pieces. There's the first quartile, there's the second quartile, which I'll label Q2, and the third quartile, labeled Q3. To find the quartiles, it's extremely similar to finding the percentiles. Step 1, put the numbers in order again, from smallest to largest. Step 2, the first quartile is found, first quartile position is n times 1/4 or 0.25. In other words, the first quartile is the 25th percentile. For the second quartile, anybody want to guess? Times 0.50. In other words, the 50th percentile. By the way, is there anything else you know of where you take n times 0.5? It's also the median. The median is your 50th percentile. It's also your second quartile. The third quartile should be a little bit predictable by now. N times 0.75, otherwise known as 75th percentile. So if you can find percentiles, you can find the quartiles. The quartiles are a bit more useful though. The reason for that is they allow us to compare how the data is distributed a little bit more. Whoops. There we go. Had a connection problem there for a second. For example, let's take a look at, I'm going to give you a small data set, and I'm going to put them in order from smallest to largest right off the bat just to make it a little bit simpler for us, make it a little bit quicker. 7, 11, 13, 14, 16, 17, what is that, 6, 20, and 28. So there are 8 numbers. To find quartile 1, or the first quartile, n equals 8 here. So 8 times 0.25 is 2, which is telling me that it is between the second and third. Between 11 and 13 is 12. Quartile 2, which is usually just referred to as the median rather than the second quartile, is 8 times 0.5, which is 4, telling us it's between the 4th and 5th. So it'll be between 14 and 16, otherwise known as 15. So the median, or the second quartile, is 15. And finally, quartile 3. 8 times 0.75 is 6. That tells us it's between the 6th and 7th number. So it is between 17 and 19, or 17 and 20, which is 18.5 is the third quartile. The reason this is important is these 3 things combine with the minimum and the maximum to make up something called the 5-number summary. What the 5-number summary is used for is something called the box plot. What a box plot does is I take a number line. So this goes from 7 to 28. So I've got a number from 7 to 28. So I'm going to go 5, 10, 15, 20, 25, 30. My minimum, what's my smallest number here? 7. And my maximum is the 28. So on my box plot at the minimum of 7, I'm going to put a little mark there, a little line there. My first quartile is at 12. So I put a little bit bigger line there. 15, I'm going to put the same size line as at the 12. I'm going to keep it lined up. That's the median. The third quartile is 18.5. That's going to be somewhere in here. I connect the first quartile to the third quartile with the median, just like that. That is the box part of the plot. Now then, my maximum is 28, so that's right up here. So from the upper end of the box, I extend a line out to that 28. From the lower end of the box, I extend the line down to that minimum of 7.